I'm very excited to be here. Actually, there is a earlier part of the story that I didn't tell you. So I was actually planning to come here on Wednesday, straight from Burning Man. But on the way from Burning Man to the airport, there were like 3 major accidents. So I actually ended up missing that flight. But anyways, I'm here, and we can now talk about the blockchain. So what I want to do today is help us together build our first D app. We're going to talk about what the F is a D app and why do we even care about it. And then I'm going to walk through a baby smart contract. It's like so tiny, but it demonstrates how you can do creation, a read, and also a update to a smart contract on the blockchain. And using that, I'll also kind of tell you about the differences between Solidity, which is the Ethereum JavaScript-based programming language for smart contracts, and how that's a little bit different from normal JavaScript. And then I'll also tell you about the state-of-the-art dev tools you should know and you should probably use. Because if you don't use the right tools, it can be very painful and very confusing. And then lastly, we're going to connect the React app, which is the front end, the UX, to the smart contract that will deploy onto the blockchain. So that is the plan. Let's get started. OK, I need to navigate to my slides. Where are the slides? All right, so cool. So D apps are decentralized applications, and typically it has a JavaScript front end, and the back end is the Ethereum virtual machine, and that is essentially the blockchain. Because the two languages are actually very similar, they work together very nicely, which is why you see this explosion of ICOs, D apps, blah, blah, blah. So we're going to learn how to do that today. So who am I? I'm Maddie Shang. I'm a self-taught developer. And like about a year and a half ago, 2 years ago, I was like trying to figure out how to do callbacks, and then async await came out, so I never have to really worry about that, so that was good. But it also tells you how new I am, so be gentle. And then eventually I ended up specializing in blockchain development, and I moved over to NLP and AI. So I think that's enough buzzwords. So now let's actually just talk about the blockchain. So why is the blockchain interesting and why is it important? Why do we even care about it? Well, it is a transparent and immutable ledger. Transparent because anyone could actually go and look at all the transactions and verify the history. And it's immutable because it's computationally infeasible for you to go back in history, change something, and then have the blocks be rebuilt. And then it is a ledger because every transaction since the inception of the blockchain, doesn't matter Ethereum or Bitcoin or Dash, is on this blockchain. It's on this ledger. And then the other really cool part is that it allows for trustless transactions. What does that mean? It means that if I'm doing work with you, collaborating with you on the blockchain, I don't need to know who you are. I just need to know who you are, who you claim to be. So that's actually like a very powerful thing that doesn't really exist outside of the blockchain world. So how do the blocks chain? Essentially, you have a box, and then you have transactions that come into the box. And then when the box gets kind of full, you kind of like close the lid, and you give it a little shake, and then the transactions will form a Merkle tree. And then what you do is you hash everything together, you get a Merkle root. And then basically you basically stamp the Merkle root on top of the lid. Kind of like when you're moving and you want to label what's in the box that you just closed. And now if you have more transactions coming in, you just take an empty box, you put it on the box that you just closed, you wait for more transactions to come in, and you do the whole process of like hashing the Merkle root and closing the lid and putting a stamp on it. But now, instead of just putting the Merkle root of the current box, you also hash it together with the Merkle root of the box underneath. And therefore, every block has a pointer to the previous block. And this is how you achieve essentially like a time-traveling abilities and the ability to verify if things are true on the blockchain. So I've included 2 links. These are from previous presentations with more detail, but I'm going to skip over that for now. So Solidity versus JavaScript. So how are they really different? And this is essentially me trying to tell you how you can quickly become a Solidity developer from a JavaScript background. So first of all, Solidity is like a lot more object-oriented. There's a lot of like custom-built objects that have different properties and rules you have to respect. For example, we have these things called addresses. We have these things called contracts, which is essentially the smart contracts. We have types like string, integers, and unsigned integer, etc. There's a documentation right there for your further reading. And then the other thing that gets a little bit confusing, especially for new developers, is the idea of data structures. So we have arrays in JavaScript, and they're typically, dynamically linked. You can put in whatever you want in there. But then in Solidity, they're either dynamically linked, or you have to specify how long you want your array to be. And also, the array, the things you put into the array have to be the same type. So that gets a little confusing. And then we have these things called mapping. So mappings are typically what you think of as key-value pairs. But then the tricky thing is all the keys have to have the same type. And then all the values also have to have the same type. You're like, well, that's kind of like restrictive. What do I do about this? Well, then you should probably use structs. So structs are the most similar to JavaScript object because you can have different keys and different values of different types. So you can typically nest these things, but you have to do it with caution. There's a bunch of little gotchas. So there are now the other thing that's a little bit different, and that is method types. And these are keywords that start to look a little bit like Java. So for example, the common keywords like public and private denote who has the ability to access certain storage variables and who has the ability to call certain methods in your contract. If it's a public method or public variable, that means any third party can access that value or call that method. So a third party could be someone with a Ethereum address, or it could actually be another contract, and this is where things get interesting. And private means only the contract itself, that instance itself, has the ability to call that method or get access to the value of that variable. And then we have these keywords, which are interchangeable. They just kind of renamed it, called view and constant. This is basically denoting that, hey, this is a method that's only going to read values from the blockchain, and it's not going to attempt to mutate any of the states in the contract. And then we have this other common method called payable. So this typically denotes that when I call this method, I'm also going to attempt to pay you a bit of ether, which is kind of nice. So here's a little bit of example. That's kind of similar to the baby smart contract we're going to go over. So as you can see, I have defined two storage variables that are public, which means anyone can call to the blockchain, call to this contract, and get the value of the promise, and if the promise was kept. And then also, we have a function called didHappen. This is actually a really dumb function. If you pay it, and anyone can call this function because it's public, it's going to return the Boolean value of the state variable if the promise was kept. So I included a link to gist that includes the smart contract we're actually going to work on. So next slide. OK, so now let's talk about the cool part. And that is the state of the art as of now, developer tools that you should probably know and you should probably play around with, because this will help you develop smart contracts and the apps with less pain. So the first thing we want to talk about is called Remix. This is the gateway drug to the Solidity Ethereum ecosystem. It's an online IDE and compiler, and it has a JavaScript Ethereum virtual machine, which means you can test your code very easily, and you can debug very easily, and this is honestly the best way to get started. And then I also want to talk briefly about MetaMask. It's essentially a bridge that allows you to manage your keys for hierarchical deterministic wallets, and also allows you to run a DApp in the browser without having to run a full node. So running a full node means that you have to basically download all the summary of the transactions, and then you have to establish a connection to the Ethereum blockchain, which takes a lot of time, probably a day or so, and it's very annoying to maintain. So with MetaMask, we don't have to do that. And if you're wondering what is a hierarchical deterministic wallet, basically it's a wallet that, giving a password phrase, which is typically 12 random words, it will be able to generate unlimited pairs of private and public keys. In the blockchain world, your private key is essentially your password to a specific account, and you should never share that. And your public key is typically your address, right? So if someone wants to send you some money, then they will send it to your public key. And if you deploy a contract, that gets deployed to a public address, which is the public key. And then Web3. Web3 is a package that we need to install to build the apps. And this is essentially the adapter that connects everything from the blockchain to everything that's the front-end JavaScript. So it's literally a essentially adapter with two outlets on each end. You plug in the blockchain on this side, you plug in your JavaScript on this side, and voila, now everything can talk together, and it's going to be super cool. And it does a lot of other things like helper functions, etc. And we'll see a bit of that. And then last thing, Infura. Infura is infrastructure that allows you to deploy to a test net or the real net without running a full node. Once again, we explain why full nodes are a little bit annoying, and maybe if you're just starting, you don't want to have to deal with that. Cool. So demo time is going to get exciting. What we're going to do is we'll walk over the code for our baby tiny like hello world smart contract, and then we're going to play around with it using Remix and the JavaScript virtual machine, so I can demonstrate how that works. And then we're going to deploy it, and then we're going to basically interact using Remix to the actual contract that we deploy to the testnet. And then we'll do some crazy stuff after, but let's actually do that. Find my mouse. OK. So if you go to the gist, I basically just copy over that code here. And then this is essentially Remix. So what I'll do is I'll walk over each of the lines real quick. So this right here specifies to oh, this is unexpected. OK, let me maybe do this. Someone said I would be able to show both screens, but we'll make it work. OK, so this first line right here specifies what version of the compiler you should be using. Ethereum is a very rapidly changing community. There's a lot of breaking changes. You want to basically compile your code using the right version, or else it will scream at you with lots of errors and bugs. And then here is where we kind of declare our contract and like how to I promise. So what this contract does is that I will basically tell the blockchain, hey, I commit to do this. And then we have another function that allows me to, or someone else to say, oh, Maddie did it or Maddie didn't do it, right? So very basic. So the contract here has basically two state variables. One is the promise, which is the message, which is a string that tells you what I promised to do. And then there's another variable that's a Boolean, also public, called did it happen, like did it actually do it or not, right? And then so every contract needs a constructor, and this is the thing that gets called when you deploy a new contract instance. As you can see, we have a parameter here that is string, which is essentially the thing that I promised to do. And then the other thing that we're doing right now is that we're setting state on a variable in a higher scope, and this works very similarly to JavaScript. I don't know if you can see this very well, so I'm going to try to make it bigger. OK. So we're just going to set it to false, because by default, if you have a promise, and unless you actually do it, it's false, right? And then the last thing we have here is set did happen. So I want to have the ability to tell the blockchain that, hey, I actually did the promise, or if I don't do anything, then I didn't change. I didn't do the promise. So as you can see here, there's many options to running this and compiling this. So if you go to the compiler, it started to compile, it's auto-compiling, we don't have any errors, that's great. So the next step is you want to select JavaScript VM, because I just want to run a local emulator in the browser and be able to test this out. So let's say I'm going to promise make it to Prezzo, on time. I don't know how to spell, and I'm going to deploy it, right? So you can now see that there is a deploy contract, and if I click on the promise, oh, look, it's basically what I said. And did it happen? It didn't happen. Oh, that's too bad. But then that's not true, because I did get here on time. So how about we call the set did happen, we call this method, and we pass in the Boolean that it's looking for. So we're going to say true. And then we're going to click on this. And if I zoom out a little bit, you see all the transactions. It's kind of like pretending to send to the blockchain. And then give it a couple minutes, and we're going to click on this again. Oh, look, now it's true, right? You're like, OK, cool. Like, this is nice, but like, this is not a real blockchain. What are we doing? It looks ugly. What do we do, right? All right, so now let's maybe get to the cooler part. What I will do next is, if I can get rid of this window real quick. Uh-oh, how do I minimize it? OK. Where did my presentation go? OK, here we go. So I want to talk about how we can actually deploy this contract to a real testnet. So what are testnets? As some of you may know, Ethereum and a bunch of other cryptocurrencies like Bitcoin and Dash started to get very expensive. So every time you do something, you interact with the blockchain, typically you have to pay a small fee. But then if you're just doing development and you have to do a lot of testing, that's a lot of money that you don't really want to spend. So typically there's essentially fake network set up where you can actually ask for some of the free test Ether or test Bitcoin or test Dash, such that developers like us could develop apps, make sure it's secure, and not have to spend real money. So we're going to be using a testnet called Rinkeby. There's actually a couple other ones like Coven or Robston. We're going to be deploying to a testnet. And that's what you should always do. Never deploy to a real net until you have tested your code. And then the next thing is I'll go over the deploy script. This is how we're going to take this contract we wrote and send it off to the Rinkeby testnet. And this is essentially the create part of the CRUD process. And then let's just do that right now. OK, so we got this going on. Let me drag this code window over. OK, hold on. OK. Sorry for the admin. OK, so let's talk about the deploy script. So what we have here is that we're importing a thing called the HT wallet provider. And we're importing Web3 because, as expected, we needed to interact with the blockchain. So what this Truffle HT wallet provider does is that it takes a like 12-word seed phrase, which is your mnemonic, and it just keeps generating key value pairs, such that you can easily test your code on the network. So which mnemonic am I using? Well, I basically started myself a new account in MetaMask, and I'm just using that for now, right? The sign-up process is very simple. You should all do it before you start actually coding. So I stored my mnemonic in a JavaScript file. I don't want to show it, but it's just literally a string that I'm exporting. And then the next thing you'll see that I'm doing is requiring a compile file. And the two things that I want out of there that I'm destructuring is the interface and the bytecode. So let's take a look real quick at what the compile file does. OK, so I'm requiring a special package that you may not have seen before. This is the Solidity compiler, right? Everything else is pretty normal standard JavaScript. And then what I'm doing is I'm providing the path to the contract. So this is a Solidity file that I literally copy-pasted from Remix. It's exactly the same code. And then so if we go back to the compile script, right here, what I'm saying is, hey, you should basically compile this code. And then I want you to give me the interface and the bytecode. So the JavaScript virtual machine and also the Ethereum virtual machine actually operates on bytecode, and this is why you have to compile the bytecode. And then, so what is this interface? This is essentially an API contract that tells JavaScript how to work with this smart contract. It will tell you the methods that's available, and also what are the properties of these methods and how you should work with it. So we are essentially doing that right now. So let's go back to deploy.js. The other couple things I want to explain is that I'm making a provider to hook into the Web3. Remember how I said Web3 is essentially this adapter. It has two ends. So this provider is essentially the thing you plug into the Web3 adapter for the blockchain side. And so what this needs is my mnemonic, which it will use to generate multiple accounts, and also the inferior endpoint I'm deploying to. Because remember, we're not deploying using guest into a full node we're running. We're deploying to inferior res infrastructure. OK, cool. So let's actually run the script, and let's see what happens there. Lost my window. OK, so let's do that. So while that's deploying a new contract, let's talk about what we see here. So this is the interface that I'm printing out, which I will need later. And this is the bytecode. Looks really ugly. And eventually, what you should say is something like, I'm attempting to deploy from this account, and it's deployed to a specific address. That's basically what I'm waiting for here. So everything on the blockchain is asynchronous, and it takes time. So just waiting for that to happen. Great, we deployed. So now that we deployed our contract, you're like, okay, cool, it's on this blockchain. Like, what am I supposed to do with it? Like, what do we even care? So what I can do now is copy this address, and then put it back into Remix, such that we can interact with the actual copy of this contract. So the first thing you need to do is change this to injected web3. And then I'm going to say, this is the address that I just copied over, that I just deployed to. I'm going to say, hey, instead of interacting with the local like fake version of the emulated contract, I want you to actually interact with the contract that's now on the Ring-B blockchain network. So we did that. And OK, cool. So this is now the contract that we just deployed. So what is the promise? Dry socks. That's a good promise. And did it happen? No, right? Not yet. But my socks are dry, so I'm going to say yes. So I'm going to say true. So this will look basically exactly the same way as before, except now it's asking me to make a commitment, actually pay some fees to be able to do this transaction. And this is, once again, the MetaMask interface that if you install MetaMask, you'll be able to get access to. So now this is a real transaction. If I make this window a little bit smaller, you will see that this is the transaction I'm attempting to make. And this might take a little while. But eventually, yep, so that transaction succeeded. So if I click on this again, it is now true, right? So you're like, cool, now we're able to deploy to a real testnet, and we're able to interact with it the way we expect to. But then what about JavaScript? What about the pretty front end? OK, so I can't promise the front end will be pretty, but I can promise you we can get it to work with React. So let's do that now. Back to this. OK. So I made a separate folder in this project, and this folder came about by just using create React app. I wanted to use create React app because it is a common boilerplate that everyone basically knows how to use, right? So the things that we need to do to make it work with your own custom front end is that we need to do this MetaMask hijacking trick. Remember how I was saying that Web3 needs a provider to talk to the actual blockchain? Making that provider setting is sometimes very tricky for beginners. But then MetaMask always injects a Web3 version into the browser. And I can prove that to you in a second. So what we're going to do is we're going to be sneaky, and we're going to steal that version of the provider, which will basically work out of the box. And then the next thing we're going to do is we're going to make a create React app, which the code has already done. We're going to set the states for the variables that we're going to try to get from the blockchain. And then we're going to make this little form to the create React app such that we can interact with the decentralized application. And then we'll make some async await calls in component will mount so we can read the data. And then we'll then make a call to the network to actually set the state for the variable that I actually do the thing that I promised to do. So that's roughly the roadmap. Let's look at the code. So if you look at app.js, I commented out a bunch of things. And the reason I did that is everything that's commented out is basically what you don't get if you do create React app. So what I can do now is I can do yarn start. So everything here that's not commented out is exactly the same thing as if you just did create React app. And if I go to localhost 3000, it looks exactly the same, right? Cool. So what I want to do now is first I want to set the state variables that I'm going to need and care about. So that's like, did I do the promise? What is the promise? What is the account balance? And what is the message? The message is basically a notification to the user to tell them what exactly is going on. Part of the problem with building a decentralized application is that everything has to go through a blockchain, and transactions take time to validate and get added to the chain. Therefore, it's very important that you tell the user what they're waiting for and tell them that, hey, there's a sign of life. I'm actually trying to do the thing that you wanted. Otherwise, your app is just going to look really slow and really crappy, right? So make sure you do that. And then the next thing I want to do is basically uncomment this part. And this is essentially just a web form that displays some data and has buttons for us to make that call to change the state variable. So basically, the contract status is nope, we haven't done anything yet. And the promise is like the default message, and we haven't been able to read the account. Why is that? Well, because we didn't actually connect Web3 yet. So this is where I show you the Web3 hijacking trick, and that is in this file, Web3 hijack. So it's actually very simple. We're going to pull the Web3 instance from the browser, and we're going to basically take that provider, and we're going to plug that into our Web3 version. So the version I'm using right now is version 1 because it allows you to use async await. If you use version 0, you have to do callbacks, and everyone knows I don't like callbacks, right? So that's all this is. So going back to our app, we basically have this imported. So now we can use Web3 with the right provider and also the right version. And then we also imported the contract instance. So what exactly is this contract instance here? So if we go to that code, basically it's everything you need to basically rehydrate and reconstitute this contract we're trying to interact with, right? So we have to provide the address that we just deployed to, and we need to include the ABI, which is the interface that tells JavaScript how to interact with the smart contract. And some of the methods here are, being able to read what the promise was, being able to, read the value of like, did you do the promise or not, and being able to set the value, etc. So at the end, I'm making Web3 basically rehydrate a instance locally so we can actually work with it with JavaScript. So let's go back to app.js. We went over these 2 lines. And this is where we actually make it try to read the values from the blockchain. And the best place to put that is component dim mount, or component dim mount. So I'm gonna now save this value, and let's see what happens. Oh look, so we just had an update. The contract status is no, promise is dry socks, and this is how much basically money we have in our Ethereum account that we're using to do these things. So cool, that's great. But then I said I'll show you how to be able to update the contract on the blockchain, and that's equally simple. As you can see right now, there are 2 buttons here that allows us to say, do we fulfill this promise or not? And all we need to do is basically add an onClick event to those buttons. Essentially, I'm getting the ID of the buttons, which one has the true value, one has the false value. Remember, our method for set did happen is a Boolean input. Therefore, I'm converting the button ID into a Boolean and then sticking that into the method call. So here I'm saying, hey, take this contract that I rehydrated using Web3, and I want you to call this method on it, and here's the parameter. And every time you interact with the blockchain, once again, you have to pay a small fee, and the fee is going to come from this account 0, which we verify has some balance, right? And then basically afterwards, we're going to tell the user, hey, we're trying to make this transaction, and this is why everything's kind of slow. It's not doing exactly what I expect. And then when that transaction succeeds, when the async await basically comes back and resolves, we can now tell them, hey, what you tried to do succeeded. And so that's the idea. So let's actually check that out. So we refreshed. We have the same value. We're able to read from blockchain. Great. So I wanna tell you, hey, like my socks are actually dry. So I'm gonna say yes, my socks are dry. Once again, MetaMask is gonna say, hey, do you want to confirm this transaction? And I have to hit confirm because that's essentially me proving to the network that I own this account that I'm trying to send this transaction from. And we're waiting on transaction success. Give it a couple more minutes. Boom, 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 boom. Once again, everything's asynchronous, and it's sometimes a little annoying. But the best thing you can do is just tell the user what's actually going on. So waiting more waiting. OK, there we go. All right, so if I refresh this page now, and the status now did. And if you were very perceptive, you would have noticed that this amount has gone down because we spent some to actually do the transaction. So there we are. I made a create React app template, and I connected to a deployed version of the smart contract on the blockchain. This is very simple, but you should have enough kind of like anchoring points to help you continue to explore. And should you want to build more decentralized applications. So where to go from here? I include a link to the repo and instructions on how to replicate this entire process yourself. And there are some comments in the repo if you feel like reading through them. The next major thing that I recommend you look into is how to test your code using Mocha, which is a common, well-understood, well-documented JavaScript testing framework, and Ganache CLI. So Ganache CLI used to be called TestRPC. What it does is that it allows you to run an emulated fake version of the local network on your computer so you can test your code very thoroughly, right? And then the next thing maybe you should look into is gas, like how much fee you should be paying, what does that do, why it's there, blocks, and block time. Because the idea of time and randomness on the blockchain isn't exactly what you expect, and those are common gotchas. And then maybe look at people solving real problems with real decentralized applications. So when someone asked me to build tennis coin for them as IPO, like ICO, I basically just lost my shit. Don't try to build tennis coin. Try to build things that are actually solving real problems. So the thing that I like is called BAT. It's called Brave Attention Token. The problem they're trying to solve is that how do you like get compensated fairly for your attention on the internet and for the data that you read and the data that you contribute, right? I'm also working on 2 projects. One's called Mercantis, and this has to do securely storing medical information on the blockchain such that doctors, researchers, and yourself has access to the right data such that we reduce healthcare costs because it's very expensive in the United States for no apparent reason. And then the other thing I'm working on is called Aegis. What Aegis does is that it's kind of my way to fix democracy. It allows you to basically make decisions and store your rationale onto the blockchain. And then afterwards, random people will vote how good your rationale is, how good your decision is. And if more decisions come up and you happen to be very good in a certain field, then your vote will weigh a little bit more than someone who has historically made terrible decisions there. So yeah. Thank you so much. Thanks for having me here. I just want to take one moment to reflect. About 2 years ago, I was trying to learn how to do like callbacks, and it was like hurting my brain. And I was watching MPJ's video, and then I saw async await, and now I never have to worry about callback again. So thank you to the Nordic.js community for helping me become a JavaScript developer.